put some music. Can you hear the music now?
No.
Yeah, because I'm only presenting the tab. Can you hear the music now? No. Can you hear now? No.
Not really.
I thought that if I share the screen and then I play something. Okay, never mind. Let's wait a few minutes and we'll start. I thought that if I share the screen and then I play something. Okay, never mind. Let's wait a few minutes and we'll start. Okay, let's give it another minute for people to join. We'll start. Okay, let's give it another minute. All right, so welcome to the meetup of December of the Data Science Milan community. I'm gonna give you a quick introduction to the community and then we start with the talk. We are an independent group that was founded on February 2016. Nowadays it counts more than 1.7 thousand members. We typically meet once a month on YouTube, and hopefully soon we'll also be able to arrange physical venue. Again, we are part of a larger group, which is the Italian Association for Machine Learning. And this is the staff, volunteers who are behind the organization of those events. And we're also looking for other volunteers to join us. So if you're interested, get in touch with us or visit our website, www.datasciencemilan.org. On the website, you can also find the recordings of previous talks, as well as the link to our blog on Medium, where you will find the summary articles after every event. You can also find a form for registering in our monthly digest. It's a newsletter with all the most relevant events, articles, news from the community, and even promotions. We use Slack for keeping in touch with the other community members. And again, on the website, if you scroll to the bottom of the website, you can find a link that if you follow that link, you'll be invited into our workspace on Slack. If you want to send a proposal for your talk, this is our email address, datasciencemilan@gmail.com. And those are our social media channels. So before we start, please help us spreading the word by tweeting about us, by sharing pictures, photos, or anything that can help us, in getting to a larger audience and helping the community to grow. Thank you very much. and enjoy the talk. So now I'm gonna introduce you to the presenters, which is gonna be me. So I'm Gianmario Spagani, and in addition to be the organizer of um, one of the organizers of the Data Science Milan community, I also work at Brinley. Let me change. Let me change presentation. Okay. I work at Brinley as Director of Artificial Intelligence. And together with us tonight, there is also my colleague Arthur. Arthur, would you like to give just a quick intro of yourself?
Hello everyone, thanks Jean-Marie for the introduction. My name is Artur Zagadu and I work as a senior data scientist at deepsense.ai, and we work together with Brainly to develop the system for automated content quality assurance, which we will describe today.
Thank you, Arthur. Okay, so then let's start. And I would like to start with giving you one insight about the education industry. In the world, if you're not aware of, there are more than 1.5 billion students who need help in their educational path. And this is why Brinley was created as a company to help them getting unstuck during their learning. More specifically, the core product of Brainly is called the community question and answers, which is um, you can see it as a sort of knowledge base where you can ask any question either by typing or just by pointing with the camera of your phone. This is a functionality called Snap to Solve. So you would point, scan any question, an educational question, and then the Brainly product will find the answer for you. And if the answer is not available, we'll ask one of the member of the community will soon give you an answer. There are more than 350 million active monthly users. As you can imagine, it's very quick, to get answers from other users. And yeah, in a nutshell, this is what the community Q&A product is, and it's used by students to guide them with step-by-step explanations during their homeworks. The mission of the AI department at Brainly is to personalize the learning experience for both students and parents. And to explain you more what I mean here, I'm going to guide you through an example. Imagine that we have this user called Liam, and Liam is visiting for the first time Brainly. Now, we know nothing about Liam, rather than he needs help for solving a math expression. So he's completely anonymous to Brainly, and what the product will return is the explanation on how to solve the math. And that's, let's say, the base product. Now, imagine that Liam is doing a few interactions with other Brainly content, and now is looking for a different subject, why the Battle of Waterloo was fought. We Brainly, in the meantime, has collected a few interactions, so has constructed a limited learning profile for the student, and now he knows that it is in the middle school grade. So out of all the possible answers for the question about the Battle of Waterloo, it will only show what is relevant based on the school grade, the mid-school grade. And let's continue. It's 1 month now, and Liam has done enough interactions. Now Liam is browsing the history subject channel, and because at Brainly we have constructed a medium reach profile, now we can also infer the interest as well as the school curriculum with some degree of accuracy, which enable us to provide the most likely content that Liam is interested in. Even if Liam hasn't searched for the July Revolution, we can sort of infer that because July Revolution comes after the Battle of Waterloo in typical school curriculum. After 3 months, we can imagine that we have a lot of interactions made by Liam, and we can start providing feedback um, to our suggestions. So, for example, we can send push notifications, and based on the fact that the curriculum is the learner profile is very rich, and we have the curriculum for Liam with a high degree of accuracy, we can even provide a tailored learning path of what Liam has to sequentially study in the following months in order to get to the goal of succeeding at the end of the year, of the educational year. So this is what we call the predictive interventions, which means moving beyond being reactive to predictive and solving future educational struggles ahead of time in order to make our students more successful in their education path. Predictive intervention is what we are building in the AI department at Brainly. And the strategy to get there is investing in a few areas. The first area is content. So using machine learning for extracting content attributes, as well as for enriching with additional metadata. Investment of machine learning in the users' attributes, so enriching the profile of the users. Visual search, which is the entry point of our product. It right now it works through the camera of a smartphone, so we need to translate images into search results. And then there is curriculum, which is the analysis on user sessions and patterns in order to provide recommender systems. Today we're going to focus on investment on content, and in particular we're going to see the domain of content quality. And to explain to you content quality, I want to use this analogy. Imagine that we have a pool, like a swimming pool, and the water is new content created by users every day, every minute. So as new questions are created, new content are created, we definitely want to apply filters based on our quality standards, as well as we want to periodically clean what's in the pool, and this is what we call the maintenance process. On top of that, once the pool is clean, we can have product features built on top, as well as AI algorithms that will use this higher quality training set as a starting point. So what are the traditional strategies, without using machine learning to maintain a clean content pool? Any social platform with user-generated content would have a community moderation process behind, which means that any user can report. Some special users can moderate, which means approving or rejecting the report, and then you send a feedback to the user saying, "Hey, your the question you asked has been moderated and removed." So it's very scalable solution for reporting and moderation, but has a few limitations. The first thing is that people can be biased and can behave unpredictably. As every human being, we should not rely on moderators to be consistent in the way they take decisions. It might introduce delays, because moderators have to manually go and approve or reject. And during this time, we are exposing low quality content to the end user, and this is bad for the user experience. It's hard to execute changes to the policies. Let's say that we change our moderation policy of what to do with certain type of content. Now we need to train all of the moderators and give them the new instructions. Okay, so this is a bottleneck. We can rely on external trusted moderation services, for example, agencies with teachers or experts in moderation, and they are really good for guarantee this moderation for the high value strategic content, for example, the content that drive a lot of traffic. But on the other hand, they can be expensive, they are hard to scale, as each agency can only provide a certain amount of experts. It's very specific to the market. Agencies don't work in every market, and also the latency and the throughput, it depends on the availability of the teachers and the experts. Another technique is called shadow banning. And shadow banning is a technique that is used for fighting malicious users when they intentionally are polluting the content pool. And it consists of hiding the reported low quality content from the platform for all of the regular users but the creator, which means that nobody can see this content, but the creator is never notified, so they don't know that they have been moderated. And it's important that they don't know, because otherwise we are giving them a feedback to learn how to circumvent the filters, and we don't want that. Okay, now that we've seen what are the traditional techniques, let's see how can AI augment the moderation process. The very first approach was taking all of the historical moderation events in the order of millions of examples and train a classifier by fine-tuning a BERT model on the task of a binary classification. So what was deleted after moderation was the positive class, and everything that was not reported was our negative class. And we can use the output for ranking and filling in the moderation queue after the predictions. What we realized though is that moderation cannot be modeled as a binary problem. And the issues with, let's call it, blind binary classifications are that the labels are not trustworthy. The fact that you don't report something, it doesn't mean it's high quality, it just means that nobody noticed it yet or bothered to report it. So because of that, you will create a training data set with noisy labels, and it's hard, for the machine learning models to learn something from noisy labels. And also the positive classes, the deletions, can happen due to autoscope reasons, for example, plagiarism or copyright. And we don't want the machine learning model to learn how to predict copyright, because there's no way to you need external information to know if something is violating copyright or not, and we cannot pretend the machine learning model to learn those rules. But also very important is that there is no explanation of why a certain content was classified as a low quality. We need to have reasons. In a typical enterprise set, you want to have reasons. And it's really hard, because of the lack of reasons, it's hard to define a single action policy or what to do with this type of content. So instead, we thought, okay, how can we properly augment the moderation process? And in the second iteration, we start modeling as a multi-label content classification problem by grouping different content labels into high risk, low risk, and a third group, which we call the request to fix. Now, high risk is something that should be immediately moderated because it can be harmful content, like spam. Low risk is something that is bad for the user experience, but is not, it's safe. You can keep it in the platform, just that is low quality. For example, if I'm asking a question about, hey, how's the weather today? That's definitely not an educational question, but it's not harming anybody. Same thing with if I ask in the wrong language, or if I ask something that doesn't make any sense. Request to fix is a particular category that instead of moderating, we can actually fix it. We can ask the user, hey, why don't you fix? This is the case of incomplete questions, or when the user asks the question in the wrong subject, or when it's badly formatted and it becomes hard to read. Those are the cases where we can ask the user, hey, you can fix it. So in this case, we can still show the question on the platform. To give you an overview of the system, let's go back to the analogy of the content pool. Now we have question asked by the user. We have the classification service, which is an ensemble of different models. The output of the predictions go into a function, which is our ensembling function, and defines the rules for filtering and preventing users to create those low quality questions. And then periodically we would take a sample from the pool and would manually annotate and use that for retraining the new label data. But at the same time, we also want to keep a snapshot of all of the questions in the pool and calculate those low quality predictions and serve them as sort of attributes, like a data set with all the pre-calculated predictions. This is what we call the blacklist feed, such that the client applications that are consuming the content at Brainly, they can now filter out based on what is available in the blacklist. To talk about the tech stack, the top down, in terms of natural language processing models and libraries, we are using Hugging Face, we are using Perspective API, Fast Text, Stanza, and Spacing. When it comes to more general machine learning frameworks, we are using PyTorch, scikit-learn, and Neptune AI for tracking experiments. In terms of development, is the typical Python development, plus we're using Plotly and Dash for creating our demo applications. And when it comes to the infrastructure, we are deploying everything on top of Amazon Web Services. Some of the components are done with SageMaker, and some other components are microservices packaged into Flask web server and deployed on Kubernetes via Terraform modules. Now I'm gonna give you a demonstration of how this ACQUA system works. So follow me. Let me pause it. Let me increase the quality, and let's go full screen. Okay. All right. So this is a demonstration app that we use for showcasing how the system works, both to meet up events like this one, but we also use it internally with our stakeholders. Okay, let's start with a very simple question like, hello Brainly, this is a question to test the app. So this has nothing wrong in terms of quality labels. So when we submit that question, we see that in the results, none of the supported labels, at least this demo app, is developed only on those 5 set of labels: spam, nonsense, personal identifiers, toxic, and non-English. And in this case, none of the 5 were detected, as we would expect. Now let's try to change that question and replace it with something else. This is an expression of in Polish means good morning, ladies and gentlemen. So if we send these instead, the models, as we would expect, it's non-English, and this is quite trivial. It's a simple language detection. Now let's go into more interesting use cases. If we send hate speech, like I hate people, okay? In this case, we can see that the toxic model was giving a positive prediction, and by switching into advanced mode, we can see more specifically the score. This is 88 probability. It is quite this model is quite calibrated, so we can actually interpret that as a probability of being toxic. 88, quite high. Now let's try to replace the question with something different. Now we have a mathematical problem. What is the solution of x equal 50 plus 2x? And we're gonna see some problems that natural language processing models have with known textual expressions, like in this case symbolic mathematical expressions. So when we ask this question, is still okay, nothing is flagged, but we can see that the nonsense model is giving a quite high value. by reducing the amount of text, by replacing what is the solution of with solve for, just by making this little change, we see that now we are creating an effect that we don't desire, which is the nonsense model detecting that question as nonsense and also as non-English. And this is a typical problem when you have those mathematical expressions, is that if you interpret them as text, they make no sense, and they also don't look like English. So it is correct that both nonsense and non-English are detected. And as a workaround, here we can see more of the metadata returned by the service. And as a workaround, we created this rule that whenever something is mathematics, we would not apply the non-English and wrong detection model for, let's say, avoiding this kind of problem. So yeah, in this case, you see, by specifying mathematics, our service would not flag it as a nonsense. Now let's go back. Let's change the subject to something else, like history, and let's try to type some gibberish here. Now, when we try to detect gibberish, it does detect gibberish as expected, but it also detected as non-English. And technically, again, this is correct, because if this is gibberish and this is not English. Another interesting insight is if I replace this completely nonsense gibberish with another type of gibberish, which is repeating, I don't know, potentially correct English patterns like why. If we submit this again, we see that the gibberish model is not detected anymore. And the reason is that the model is a sequence of characters, it's based on sequence of characters, and what WHY is sort of a legitimate pattern. But of course, if you interpret it in terms of tokens for English dictionary, then it doesn't exist. Let's change example now. Let's go into sort of follow me on Instagram. This is my Instagram handle, so if you actually want to follow me, this is me. And this time we see that the personal identifier model is triggered. As we would expect. Now let's go change use case. Let's try with some sort of spam message. This is something you can find on social platforms. Who wanna join just for fun, and this is my meet link, blah blah blah. So if you try to type this and ask this question on Brainly, then our models would flag it as spam. But again, we can see how the nonsense model also is triggered again, because this pattern, ZAD, etc., it doesn't make sense. It's not natural language. So again, I wanted to highlight what are the limitations of natural language models when we have content that is not only based on language, text. But the most important thing for us is that it's detected as spam. And to conclude the demonstration, let's try again with a completely legitimate question, educational question, which is a physics problem. If a rock 40 kilos fell from a cliff with a speed of 30 meters per second and hit the ground, what's the kinetic energy? This is a completely legitimate question, and in this case, as we would expect, none of the labels are detected. And with this, I'm completing and finishing the demonstration. And now, before I pass the ball to my colleague Arthur, you might wonder what kind of expertise were required to implement the ACQUA system. And yes, this is the team composition, if you want. It was implemented in partnership between Brainly and DeepSense. As you can see, there are different roles in the team, starting from me here. Then there are data analysts, there are machine learning engineers, data scientists, project managers, software engineers, lead data scientists, etc., etc. So together with DeepSense, we managed to scale the team and deliver this system much faster than we would if we had to start everything from scratch on our own. And now I will ask my colleague Arthur to start sharing his presentation, and he will continue the rest of the talk. Thank you.
Okay, hope you can see the slide. Hello everyone again, my name is Artur and I work as a senior data scientist at deepsense.ai, as you already know. And now let me first start with a few words about my company. So at deepsense.ai, we are a team of data science experts and we deliver AI-based solutions to the problems of our clients. We work for companies from all over the globe, for both large and small companies from multiple branches of industry. We have a proven track record of over 100 commercial AI projects. We also did work in the R&D sector together with Intel and Google Brain on topics such as reinforcement learning and generative adversarial networks. We have experts in predictive analytics, computer vision, and NLP on board, and we use our expertise to develop end-to-end solutions to satisfy the needs of our clients. Currently, one of our clients is Brainly, who we work together with to develop this ACQUA system that Gian Mario just introduced you to. And my part will be focused on the lessons that we learned while developing ACQUA, which stands for Automated Content Quality Assurance. Lesson 1. Manually annotate a data sample to better understand your problem. So first of all, I must say in this Brainly project, we are quite lucky because we have access to a lot of data. For the purpose of this initial stage of this project, which we are describing in this talk, we have established a dataset consisting of several million questions posted at Brainly by the users in the US market. And the dataset also includes contents that were moderated or deleted by the moderators for a variety of reasons. But at the same time, we are also unlucky because the dataset is unlabeled. As you already know from the previous part of the presentation, we cannot really treat moderation information as a reliable source of ground truth labels for content quality classification because they are not a reliable indicator of content quality. So we decided to actually manually label a random sample of a few tens of thousands of questions, which serves as our evaluation benchmark so that we can compare different approaches, compare the performance of different models that we train. And we did this labeling following a so-called multi-label scheme, which means that not only a single category, but more categories can also be assigned to each question, each content. The categories come from what we call content quality taxonomy. And on the right side of the slide, you can see more or less how the labeling job looked. So there were labels for marking questions as spam, as being written in the wrong language, not suitable for a given market, so not in English for US, nonsensical contents, contents that were incomplete and therefore unanswerable because some piece was missing, which was required to provide the answer, questions assigned to wrong subjects, contents that were hard to read, etc. There were many more categories than those listed here. It's just a selection, a subset. And apart from that, of course, in parallel, we are also continuously gathering more and more data with annotations required for training proper machine learning based models on top of them. So now I would like to share with you some observations, some conclusions based on our experience with this multi-label annotation, which definitely is not an easy task. So first of all, do it yourself or with your team, at least in the beginning. I mean, before you decide to send the data for some external company, for some agency to do it for you, you should spend some time to annotate on your own not only to better understand the problem and the data itself, but also to better set up the guidelines, the instructions for others for the future annotations. You should be also providing as many examples as possible, including corner cases, to avoid unnecessary confusion and also to avoid unnecessarily wasted money, because it's also a costly process. Second of all, you should make the process iterative, which means it should be handled in a step-by-step manner with continuous feedback provided to the annotators, so that the contents should be labeled in batches, and after every batch you should be updating your guidelines, your instructions, providing more examples, so that over time, as time goes by, your quality of labels and the level, like the number of mistakes done by the annotators is reduced, as well as the level of inconsistency. I can assure you that the content will surprise you, because you never know what to expect when it comes to textual data, especially if the data comes from a community as creative as the Brainly users. So you should actually always put a category called hard to tell or other in your labeling scheme, so that the annotators, whenever they are not sure what to pick, they can have a fallback option like this one. And last but not least, you shouldn't really rely on a single person's decision. So each item should be annotated by more than one annotator to avoid the impact of decisions of a certain individual on the quality of your labels, and therefore also on the performance of your models that were trained on them. Continuing the topic of data collection, we also took advantage of the zero-shot classification approach, which I will describe in this slide. We used it for obtaining questions that were likely to be of low quality, and this is how we did it. So the transformers library offers a pipeline for so-called zero-shot classification, which is about giving predictions without any training examples. And this zero-shot classification model in transformers is actually a model that was trained for the so-called natural language inference task, NLI. In simple terms, this task is about models that take as input a pair of texts and return a score representing how, let's say, related these two texts are. And as I already said, we used it for collecting candidates for low-quality questions. And we looked for these candidates among questions that had high scores from the model for so-called entailment, which is in this NLI task word, a synonym for relatedness, let's say. And we checked for this entailment against labels such as spam, nonsense, and toxic. And then we manually verified those predictions and extended our training data set this way. So you might be wondering what I mean by entailment with the labels. So actually, each of the categories has to be represented as its textual descriptor, as a sequence of tokens, as a text, and then the query sequence, the question in our case, or the content from Brainly can be checked against or checked for entailment with each of these labels separately. And in this case, probably high scores would be assigned to this is spam and this is social media labels. Okay, lesson 2, analyze patterns in your data to find potential pitfalls. So before you start to blindly apply machine learning to your data set, you should first dive deeper into the data itself to try to notice some patterns in your system's user behavior, and maybe come up with a, let's say, quick win solution to the problem which the behavior is causing. In our case, the problem was that the users were successfully circumventing the previously deployed spam filter, which was based on a regular expression, and we found a way to make it more robust, to make it better without any machine learning, actually, just by extending the already existing solution. So here you can see examples of these circumvention methods. So users were replacing some characters with, for example, digits. They were inserting white spaces or other characters in between, and this allowed them to successfully go through the filter. And let me also tell you what we consider spam. This is any kind of URLs, advertisements, any reference to other platforms such as social media or messaging platforms. And last but not least, something very Brainly specific, which is the case of users giving so-called free points to each other. Points in general at Brainly are kind of a prize for help in learning, but users also very frequently give their points for free for no help. This is also something we want to prevent and detect. And our quick win solution, as I said, was an augmentation of the already existing regex. And it works on top of an extendable blacklist of prohibited words. And the words were very carefully selected to ensure the high satisfactory precision of the predictions. The solution is also robust to character repetitions and substitutions with other characters, as you can see in the example on the right side. These attempts of circumventing from the example are no longer allowed at Brain, thanks to our quick win solution. Another observation which Gian-Mario already told you about is that mathematical expressions can be actually quite problematic for NLP models that were trained on language data only. So in case of this content that was already presented, you saw that it made the models for wrong language and nonsense detection go above the threshold and predict a positive detection. So to mitigate this issue, we are also, apart from ignoring these models for mathematics subject, is just a temporary solution, which is far from perfect. And right now we are starting to develop our own in-house mathematical expression detector, which would allow to mitigate this issue better. Lesson 3, NLP state-of-the-art offers many ready-to-use solutions. So apart from trying to develop our own solutions, both quick wins and also machine learning-based solutions, we also decided to have a look into what's available online, what others did that suits our needs and can be incorporated into our system. And actually we found out that there exist at least a few solutions, some pre-trained state-of-the-art models, such as, for example, those that we found for toxicity detection. There are two such tools. The first one is Detoxify, which is a library provided by Unitary. This is like an open source solution. On GitHub you can find weights for the models. There are 3 transformer-based models. One of them is even multilingual, so it supports not only detection in English but also in other languages. And another tool is called Perspective API, which is created by Jigsaw, which is part of Google. And this perspective is in the form of an API which we can send requests to and obtain scores for toxicity of text. And both of them proved useful and are now part of our toxicity detection component. Regarding language identification, we experimented with 2 libraries, so LangDetect and FastText, and I will have a separate slide on that, so wait for it. Another category is this nonsense label. Right now we are using a tool called gibberish detector, which detects, as you could see, some nonsensical contents quite nicely. And last but not least, for personally identifiable information detection, we played with Microsoft Presidio, and the tool in general was not perfect, but some parts of it inspired us to develop our custom solution. Okay, regarding language identification, as I said, we experimented with 2 libraries for detecting non-English contents in the US market data. And the simpler one is LangDetect, which works on top of character n-gram frequencies trained from training corpus for a given language. And the second one is FastText, which is a classifier trained on top of FastText word embeddings. And comparing these 2, we found FastText much better, but it got even better when combined with lang detect, with the intersection of both models, gave a precision of more than 85%, which was satisfactory. Of course, it was not perfect again, but there were some typical false positive scenarios, including texts that were too short to be representative for a given language, texts that were nonsensical, and the already mentioned mathematical formulas. And lesson 4, hard problems can be broken down into smaller and simpler ones. In this lesson, I would like to focus on one of the sub-problems that we are trying to solve, and this is the case of incomplete question detection. Incomplete means that the question in general seems okay, it's proper educational content, but some part of it is missing, some piece is missing, which doesn't allow the person who would like to help to provide the answer. And this, unfortunately, is quite a frequent issue at Brainly. And initially, we wanted to treat it as a binary detection, like detecting whether a question is incomplete or complete. And it seemed a difficult task for machine learning. Actually, it's also quite tricky for a human to determine whether a question is complete or incomplete. It also requires some domain knowledge to do that. So we also decided to dive deeper into the data, into the questions that were labeled as incomplete in the first iteration. And we identified 4 major sub-problems that potentially can be tackled separately. So we found questions that are missing some context, which is frequently or should be provided in the form of an attachment. You can see on the right an example of that, where some map is missing and the user cannot get the answer. You can see in the answer that the person who would like to help cannot, because there is no picture provided. Another category is called what we call missing question. So there is some text, something that might look like a school exercise, some homework, but then the actual question is missing, and we cannot really tell what the expected answer is. As you can see here, the user came up with some very random answer, probably looking for easy points for, let's say, help. But he also said that please be more specific because I cannot really help you. Another category is what we call missing choices. This is about multiple choice questions, MCQs, which are questions which in general require some options to choose from. Here again, in the answer, you can see that the person is asking for the options because they were not provided in the question itself. And last but not least, some contents are also truncated, which means that in most cases the ending is missing, as you can see here. And again, someone came up with an answer which definitely is not correct because he has no chance to know what the question was really about. And the answer is also marked as low quality, as you can see. So let me tell you a bit more about our solution, our baseline model for detecting this missing question type of contents, which is a combination of heuristics and natural language processing. And let me show you yet another example. This question is about some Nick who is putting his $10 into a lunch money, and then he spends $2 each day until his balance reaches 0. And this is it. We cannot really tell what the question is about. So to detect such cases, we started with thinking about what potential types of proper questions might actually appear, what types of questions might be answered. So the list starts with WH questions, so which, who, where, what, when, how, etc. Then yes or no questions, true or false, fill in the blank type of questions, so that there is some placeholder filled with some expression by the student. Then multiple choice questions, and last but not least, contents that contain some verb in imperative mood, such as explain, describe, show, prove, etc. So this list was an inspiration for our algorithm, which I will now describe. So the first step of the algorithm is to split text into sentences with help of an NLP library for text segmentation. And then for each sentence, first of all, it checks for presence of certain tokens, which represent the WH questions, true or false, yes and no, and fill in the blank. Then it checks whether a question is multiple choice with help of a custom developed by us regular expression. And in the last step, it checks whether the verb, if there is a verb present in a sentence, whether its mood is imperative. For this one, we are using the stanza library, and there is a recurrent neural network-based model which does the part of speech tagging and also some additional morphological analysis. And if none of the conditions is met if there is no sentence in the text that matches any of the conditions which predict that the question is missing. So it might seem naive, but works quite reasonably, and of course it's just the beginning, just a baseline solution that we will improve in the future. Okay, let me summarize the presentation and also tell you a bit more about our future directions. So let me repeat the lessons we learned. 1. Manually annotate a sample dataset to better understand your problem. 2. Analyze patterns in your data to find potential pitfalls. 3. NLP state-of-the-art offers many ready-to-use solutions. And 4. Hard problems can be broken down into smaller and simpler ones. And regarding the future, of course, we are already working on improving the current baselines which I described, with models properly trained on more brainly labeled data, which we are continuously gathering. We are also planning to conduct interesting research in the following topics. This already mentioned mathematical formula detection, subject classification, detecting questions which are non-educational or off-topic. We are also trying to use these interpretability methods for NLP. We are also experimenting with weak supervision of models using Snorkel library. And for a smarter data annotation, we are planning to leverage active learning framework. And we already started expanding our solution to other markets apart from US, and it also means that we have to make it work for other languages, which will be a challenge, but definitely an interesting one. In general, this is a very interesting journey which aims at content quality assurance with help of AI. So this is it. Thank you for your attention. I hope you enjoyed our presentation. We will be more than happy to answer any of the questions that arise. You can also contact us after the meetup via email. Thanks.
Thank you, Arthur. That was really good. And also, if you would like to be part of, what Arthur mentioned as the future directions, both Brainly and DeepSense AI are actively hiring for a bunch of roles, ranging from data scientists to machine learning engineers, MLOps engineers, at different seniority, from senior, junior to tech lead roles. So, wanna learn more about, you can reach out to me or Arthur, or just visit the careers section of the websites of Brainly and the website of deepsense.ai. All right, now let's wait a few minutes. Please don't be shy. If you have anything you would like to know more about, type into the chat in YouTube. We're gonna stay here a few minutes to make sure that everybody has the opportunity to type if there's any question. Otherwise, the recording is gonna be available to watch offline, and we're also gonna publish the slides on the Data Science Milan website, in particular to our SlideShare channel. And yeah, and this seems it. I don't see anybody now asking questions at the moment, so thank you, everybody. Thank you, Arthur. Thank you, Fabio. Thank you, all of the organizers of the Data Science Milan community. And enjoy your holiday, your Christmas holiday, and I'll see you in January.
Thanks, and Merry Christmas, everyone.
Wait a moment. We do have a question. Okay. I think this is for you, Arthur. How do you handle experiment tracking?
Okay, so as you could see in the tech stack slide that Jean-Marie was presenting, we are using a tool called Neptune.ai, which I highly recommend for not getting messed up with your experiments, especially if you're doing a lot of them in parallel and you don't want to lose track of your experiments, then this is one of the tools I recommend, Neptune.ai.
Yeah. And actually, we see pretty soon we are publishing a case study. It's going to be published in the Neptune AI blog. It's going to be a different case, not the ACQUA use case, but is the use case with the visual search team. And you can learn how the visual search team at Brainly is using Neptune for tracking all of the experiments on training different computer vision models for content detection and document layout analysis. I hope it's going to be published soon, I guess early January. So stay tuned. Okay. Don't see any other question coming in, so thank you very much. Thank you, everybody, and enjoy the rest of the evening and enjoy your holidays.
Thank you again.
Thank you. Bye bye.